Hi, I'm Rick from CEI. I wanted to show you the rotary coupling for the CXP-12 cables that we have. This is our Keysight VNA. It has TDR function enabled, and we generally check the cables for impedance, and this is an impedance graph right now of this particular cable assembly. Actually, we're looking up to the past the rotary connection on here. Point number 1 on the scale is actually the beginning of the first HDBNC connector on the cable. So everything before that is actually inside the tester. And you can see that we have got a pretty stable 75 ohm impedance for the assembly so far. What's important here is that this little dip here is actually the HDBNC connector, and that's pretty typical of what we've seen. The deviation is within the tolerance of the CXP-12 spec. But very important is right here in this section is the rotary coupling. So Ray can show you the rotary coupling. So we have a test fixture that we developed. We have 2 rotary couplings. This way we can do 360-degree rotation in the same center line, same axis. So right now the TDR is actually showing this area right here, which is the rotary connection. And the TDR's display actually kind of stops showing it right here at this connector. So everything past that is in the loop, but it's not actually showing on the display. And then what I'll do is I can rotate the union. And if you want to zoom in on here, you can see the union's rotating. You can see I can go a full 360 degrees. And I'm going to continue to keep rotating it, and I'll go back and point to the TDR. Now the sweep is a little bit slower than I'm rotating it, so I'm rotating it kind of extra slow, but you'll actually see that the profile of the cable, the impedance profile, is very, very minimally affected by the rotation of the rotary coupling. And in fact, this entire assembly has 2 rotary couplings in it, and it looks very, very cable-like. I can show you one more thing on the TDR. I can also show you the insertion loss. So this is an insertion loss graph from, let's see, this is up to 18 gigahertz insertion loss. So point number 1 on this graph is only 4.5 megs, but point number 2 is 1.479 gigs. So this red line represents the area which the CXP cables can communicate at, which is up to 6.125 gigahertz. So the spec for this with the CXP spec is got to be below this red line. And you can see throughout the whole CXP range, we're well within spec for insertion loss.